All right. Thank you, everybody, for joining today. We're giving a couple minutes for people to get in. Yeah, we do have a lot to cover, so give it one more minute. All right, I know that wasn't a full minute, probably not even close, but it looks like we've stabilized with the number of people joining. So let's go ahead and get started. Again, thank you everybody for joining us today. I'm very happy to have Mike Hess with the COPD Foundation. Mike is an RT, respiratory therapist, and he will be talking about POCs with me and definitely giving the medical respiratory therapist perspective on POCs and the importance of oxygen therapy.
Thank you, Mary. It's a pleasure to be here today. I appreciate you giving me the opportunity, and hopefully we'll help people learn a little bit more about medical oxygen.
Yeah, that's the goal, right? So if you're not familiar with Running on Air, we are a nonprofit, and our main mission is to help others breathe more easily through access to oxygen appropriate to their needs. We are on social media and we do webinars throughout the year. We are actually looking to do a little more advanced POC webinar on maintenance of POCs. So that's in the works. We'll post that on social media once we have that. And Mike, if you want to talk about the COPD Foundation's projects.
Yeah, absolutely. So again, I lead all of our medical oxygen education and advocacy programs at the foundation. As part of that, we have several things we like to highlight. First and foremost, we are a relatively new project, the World Oxygen Collective, which meets the first Wednesday every month at 10 o'clock Eastern. This particular group, it tends to be a little bit more on the scientific, medical engineering side of things, but we at the foundation believe very strongly that it's absolutely critical to have the end user / patient voice included in all of these conversations. So anybody is welcome to join that. Again, that registration link is on the screen there. Our more patient caregiver focused support group / discussion group, Oxy Talk, is the second Wednesday of every month at 4 o'clock Eastern Time. And again, the registration link is on the screen there. That is always a great chance to learn from one another, to ask questions, again, regardless of why you're using medical oxygen. It's not for COPD or anything like that. We've got people with pulmonary fibrosis, pulmonary hypertension, bronchiectasis. We have a wide range of groups. And every now and then we have even a wide range of countries. We had somebody join us from the UK last month. So that was cool. And then finally, our big annual campaign, World Oxygen Day, on 10/02, October 2nd every year, where we work with a lot of our domestic and international partners to highlight critical issues in medical oxygen access and see where we've been over the last year and see what's coming up next. Last year, we had an innovation summit where we had some newer technologies that are coming out. We're looking to do that again this year, and we're also just now starting our main planning event for that. So if you have ideas on what you'd like to see, particularly if you're with one of those advocacy partners, I'd love to hear from you, and you'll be hearing from me soon. So thank you.
Sorry about that, Mike. That wasn't meant to rush you.
No, like you said, we have a lot to cover today. So,
all right. We want to thank Insumed for supporting this webinar today. Without their support, we wouldn't be able to bring you the programs that we do. So a little bit of housekeeping and then we'll get into things. So this webinar is being recorded and we will email out the recording once it is up online. So we will not be taking questions during the course of the presentation. I know it says webinar, but during the course of our presentation. If you have any questions, you can put that in the Q&A and we'll get to as many as we can during the webinar. We cannot give medical advice, and you will receive a post-webinar email from Running on Air in the next 48 hours with links or resources that we mentioned during today's webinar. So the things that Mike just talked about, the events, those will be included in that email. So you don't have to worry about screenshots of QR codes or website names. We'll be sending all of that to you. And disclaimer, want to mention that because a POC company or a company is mentioned in this webinar, it does not constitute an endorsement. We are providing this webinar for informational purposes. We don't recommend any specific POCs, and but this is for information only. And I saw somebody raise their hand. A reminder, again, put your questions in the Q&A and we will get to them after we move on. And Mike, if we can take turns, maybe monitoring the Q&A during the course of the webinar.
Yeah, absolutely. We already had one question pop in and I answered that. Are there any portable concentrators that go over 3 liters a minute? Unfortunately, no, but yeah, we'll get to them as many as we can.
Great. All right. So what we're covering today, we're going to give Mike will give a short little talk about supplemental oxygen therapy. Then we'll go on to continuous flow versus pulse flow and conserving oxygen. The basics of how POCs work. We'll talk about FDA approved POCs, and then we'll talk about non-FDA approved POCs. All right, supplemental oxygen therapy.
Yeah, so that's a very common question that we get at the foundation, at least, especially on a lot of these talks or on our social media and so on and so forth, is why do I need oxygen? And so the way our body works is, we take in oxygen from the air around us, it goes down into our lungs, and then there are these little air sacs in there called alveoli that have very tiny blood vessels, and the walls of the alveoli are thin enough that oxygen can get into the blood and carbon dioxide can get out of the blood. And when you have healthy lungs, that works pretty well. Unfortunately, because things are so small and everything else, it's very easy for some of those things to get messed up in various ways. For people with pulmonary fibrosis, you may have thick walls that prevent more oxygen from getting across that barrier. For people with COPD, particularly on the emphysema side of things, you may have fewer of those alveoli because that's part of emphysema, is some of those coalesce together. And ultimately what it is there's not enough oxygen in the regular air to get into your blood at a level that is helpful to your cells and organs. So we administer supplemental oxygen, medical oxygen, oxygen therapy. It's got several different descriptors on it. In order to change the equation a little bit, if you think back to chemistry class back in high school, by putting more oxygen in the gas coming into the lungs, that puts more pressure to help it get into the bloodstream a little bit better. And then that way you can actually have the fuel that your cells and organs need in order to work properly and to run that metabolism. So that's the long and short of why we do that. It is considered a drug, because there are certain regulations around it. And so that's why it does require a prescription. And also it's really good to have your team on board to make sure that you're getting the equipment and the support that you need.
Thanks, Mike. All right, conserving oxygen. Continuous flow versus pulse flow. So this chart gives an idea of what, hopefully shows you what this means. At the very top, you can see continuous flow, and that line goes all the way across. The numbers up at the very top are the seconds. So we're doing 1 minute, and you can see continuous flow goes all the way. Oxygen is constantly flowing through the cannula into your nose. Pulse flow is basically intermittent. It's typically based on when it detects a breath. You're taking a breath in, and it delivers a pulse, or you might hear called a bolus. And it's this amount of oxygen that it gives to you. So depending on your breath rate, and we've got from 12 breaths per minute, 15, 20, 30, and 40 breaths per minute. You can see how that goes across. And you're going to get more of those boluses, more of those pulses, the faster you're breathing. Let me go back here for a minute. So the idea of of most POCs of the pulse is to conserve that oxygen. So you can see that with the continuous flow, it's going no matter what, whether you're breathing in or out. With the pulse, again, it's doing it when it detects a breath. So the idea is it's conserving oxygen. With POCs, that means it's conserving the battery.
Yeah, so I'll jump in there a little bit also to give a little bit more
Please.
context because there's a couple of different schools of thought. Of course, with the continuous flow, you're getting that flow all the time, and the positive of that is, well, let me back up even more. A lot of people say that that might be wasted because if you're not inhaling it, then it's sitting there and then you blow it back out and so on and so forth. But there is a certain argument to be made that that oxygen does accumulate in your sinuses and some of your upper airways. And so if you have a sudden change in your oxygen demand, like if in 45 minutes or so, when you're done with the webinar and we get up and start walking around a little bit more, your body is going to need more oxygen right away. And so it can compensate for that. But again, going back to that very first question we had about the 3 liters a minute, most portable devices, or there is no portable device that can go higher than that, and most are under 2 liters a minute. And so some folks need 3, 4, 5 liters a minute of that continuous flow. And so the idea is that the machine can't do that. But what it can do is it can generate some oxygen. It can concentrate it from room air, put it in a little holding tank, and then deliver that when you inhale. And so you're getting, again, theoretically, that maximum benefit as you're inhaling and can use all of that still within the bounds of the machine. That, again, provides a little bit more wider range of potential users for it, potential people who can benefit. It does save some of the battery life because the higher the settings, the higher it has to work to concentrate that oxygen, the more electricity that takes. And then there are also some tanks. I know that's not really the thrust of this webinar, but there are some of the portable compressed gas tanks that also use those compressed gas regulators because that helps the tank last longer. So again, these aren't inherently not a theme you're probably going to hear through a lot of this is there's not one system that's inherently better than another. It's really what's going to fit the individual person's needs.
Yeah. And there are some people who can't use the pulse. They can't take in a strong enough breath to trigger that response. So it's also important that if you're looking at a pulse device, that whoever's giving that to you, whether it's the DME or, the doctor's office, eventually checks to make sure that you're able to trigger it when you need it so that you're getting that consistent oxygen.
It's always very important to take it for a test drive and make sure that your oxygen levels stay up and the machine is working the way it's supposed to. There was a survey that came out, I think it was about 2018, 2019, through the American Thoracic Society that a lot of people said that, honestly, my oxygen equipment just doesn't support my oxygen needs because there are a lot of times where nobody checks up on anybody for a wide variety of reasons.
All right, so we're going to move into portable oxygen concentrators. So just understanding the basics of how they work. So I think Mike mentioned this earlier. The air we breathe is about 21% oxygen. So that's a lower concentration. It's about 78% nitrogen. And then the difference is some other molecules that don't really make a difference for us. So the way the POC works is nitrogen is filtered out through sieve beds. There's a device or material called zeolite that filters out the nitrogen. The nitrogen sticks to the zeolite and it concentrates the oxygen. And so one of the issues with the sieve beds is that they need to be replaced periodically. Some POCs, you can do that yourself. Others, you have to send them in to have them changed. So POCs usually need about 2 minutes to get to full oxygen concentration. So if you turn it on and put that cannula right in, you're not getting that high level 90% oxygen concentration yet. And the POCs are also usually good up to about 10,000 feet of elevation. The one other thing I want to mention that isn't listed here is most of them are also good at the rate of 40 breaths per minute. At the most high end. Resting is around 12, 15 breaths per minute. Anywhere from 12 to 20 is considered a resting breath rate. 40 breaths per minute would be a little heavier exertion, definitely. And most POCs are pulse only. So again, they only deliver when breath is detected. Mike, anything else you want to add with any of these?
No, I don't think so. It speaks a little bit, the sieve bed speaks to why we can't have the higher concentrations or the higher flow rates in a portable concentrator because, like any filter, the smaller it is, the less it can actually filter through. So when you have the big units on the floor that can go up to 5 and sometimes even 10 liters a minute, those are big, bulky, they draw a lot more power. You have to make those compromises when you get down to make those portable. And so that's why when I responded, I made the comment that the physics isn't quite there yet. A lot of people may know I'm a bit of a Trekkie, and Mr. Scott would always say, you can't change the laws of physics. And that's where we're at right now with portable oxygen, although there are some things on the horizon that could be interesting over the next decade or so.
So things that are important to know, the settings are not the same as liters per minute. And you might see levels. Most FDA approved POCs call them settings, but you may hear people refer to them as levels. Settings or levels, they're not the same as liters per minute. And the settings are not standardized across all POCs. Liters per minute is the output rate. So when you get a prescription for 3 liters per minute, that's the rate at which the oxygen is being pushed through into your lungs. And that is different from the oxygen concentration. And that's what we talked about on the previous slide. So the oxygen concentration is the percentage of oxygen being provided. And the reason I'm making this distinction, because this is something that I see a lot in some of the Facebook groups or questions that people ask in webinars. So we tend to be focused on the liters per minute. There's the assumption that the device is giving us a high concentration of oxygen. So if we see, and we'll get into more of this later, any of the FDA approved POCs do have that higher, somewhere between 86 to 96%. And they're usually more in the 90s. It's if they're really working hard, if you're really breathing hard, that they might dip down into the high 80s.
Yeah, it gets really complicated, as we can see here. It gets very complicated because, as you said, nothing is really standardized here. I often refer to it as it's like settings on a radio. I get in my car and maybe my radio is set at 20, and I get home and turn on my stereo and I put it on 20, and it's a lot different experience, I'll tell you. So it's how much oxygen is being provided per breath. Sometimes some different manufacturers can do sometimes different things. They'll give you the same little puff or bolus size each time, but some will give whatever, they'll create a certain amount of oxygen per minute and then divvy that up. And so again, it gets really complicated. And where that's important is if you happen to switch machines, if you buy a new one or you acquire a new one somehow, your setting of 2 may not be the same on, for example, a rhythm as it is on an Inogen or an Oxygo or what have you. So again, it's really important to use your measurements, your oximeter, to make sure that you are getting appropriate oxygenation.
Yeah. And one of the things I have seen sometimes with the POCs is to have your doctor write the setting prescription. And this is an example of why they can't do that. The doctors don't have every single POC and every single setting memorized. Can you imagine how long that prescription would be? Well, if you're using this one, then it should be this setting. So just as an example, if you can see the red line that just popped up, that's at 0.7 liter per minute. And for most of the POCs, it's going through the setting of 4. But down a little lower than middle, it's actually setting 3 for that. It's actually one device. It's 2 different companies that are selling the same model, which a lot of companies seem to be doing. Aria in particular, I'm not sure that they have any of their own models. They usually are rebranding and reselling other models as their own. And then if you look at the very last one, Precision Medical, that's a 5 setting down there. So we have 3 different settings to get that 0.7 liter per minute pulse. Now, this is an older chart. I'll quickly show. I will say that they seem to be coming a little bit more in line with each other. You can see some slight variations, but there is still that one. It's on the 3 setting where that 0.7 comes up. I also wanted to mention that when a lot of times people say, what do you think is the best POC? Again, you can see here the different levels, the different settings, the different amount given at each setting. It really is what's best for the patient.
And not only with the settings, you can see they weigh different amounts, they have different battery lives, they have different loudness. There are a lot of factors that go into deciding it. And we really need to get into the idea of personalized treatment. Again, for whatever disease state it is, there's not a best, there's a best for you.
Right. And the first thing with the best for you is what's going to provide you enough oxygen. So within the POCs, there's 2 different delivery types. So we did talk about continuous and pulse flow, but with the pulse, they have either what's referred to as a minute volume or a fixed volume. So the minute volume means that the POC is delivering a set amount of oxygen in a minute. So it adjusts based on your breath rate. And that's what this chart over on the right shows. So there we go. So at that 5 setting, you can see that as the breath rate increases, the amount of oxygen that pulse or bolus is actually decreasing with each breath. But you're going to get the same amount over the course of a minute. The fixed volume means that the delivery, for the most part, stays the same. So you're getting the same size bolus or pulse with each breath, for the most part, no matter how fast you're breathing. So a lot of the charts will actually show if you are breathing at that 40 breaths per minute, it doesn't sustain that at the highest level, and it usually drops down a little bit. But this is an example here that I took from a white paper that was written by Valley Inspired Products. And most of these POCs are no longer available, or they've been discontinued. You may still be able to get them, but they've been discontinued, except for the Xenolite up at the top. So you can see the Xenolite is a fixed volume. So no matter what the breath rate is, down at the bottom is showing the breath rate. It remains the same. And this is on a setting of 2 that this graph is showing. Whereas the others, which are minute volume, you can see that that breath rate is declining, or the bolus size is declining the faster that you're breathing. So that's just to help you understand the difference between the 2. Again, one is not better than the other. It's what works best for your needs. And now we're going to talk specifically just the FDA approved POCs. So I'm calling this page 2 out of 3. You have a wish list, but you only get 2 out of 3 of your wishes with an FDA approved POC. So you can have high liter flow. You can have a high concentration of oxygen at all liter flows. And again, let's just emphasize that all liter flows and be lightweight. You can only have 3 of those. So FDA approved are that high concentration. So that means they can either be lightweight and low flow, or they can be high flow and they're going to be heavier. But also, as Mike mentioned, there's that technology component that plays into it. So with the current technology, with the sieve beds, as he mentioned, but also with the batteries, you might get a lighter weight POC, but maybe the battery doesn't last that long because battery is going to add weight to it. So these are all things that go into the consideration when you're looking at either renting or purchasing a POC, and to keep in mind. And in particular, when we move into the next section about the non-FDA approved. So the FDA approved requires a prescription. It has that higher concentration, 82 to 96%, but usually they're in the 90s. And part of the reason for this too, they go through rigorous testing. In order to get approved by the FDA, they have to file a 510K. And then they have to show all the testing that they've done. And this is to make sure that there's nothing dangerous. So oxygen, and Mike, if you can speak to this too. So oxygen, a lot of people think is flammable. We have to put that sign up in our window if we're using oxygen at home, right? To warn the fire department. And it's not that it's flammable, but it really feeds flames. So Mike, if you could talk about that.
Yeah, so you're exactly right. There's this thing that's called the fire triangle. You have to have 3 things for that. You have to have heat, you have to have a fuel, and you have to have oxygen. So oxygen in and of itself does not generate a flame, but it does make things burn a lot faster. And by things, I mean stuff like your tubing or your clothing, if you have your cannula near here, and especially on a continuous flow or things like that. So if you're around a spark or something like that, something that might not normally catch on fire, it would be like it was soaked in gasoline or gasoline vapors or things like that. It'll burn a lot faster, it'll burn a lot hotter and more intensely. And that's really where a lot of the issue comes in. And so that's why it's really important to have a lot of this testing, because you want a machine that is going to be reliable, isn't going to have any kind of internal risk of shorts or electrical shorts or things like that. You want to make sure it's made out of decent equipment, that the sieve beds, the zeolite in there is made out of a decent quality material, and it's capable of providing medical equipment grade therapy. Just as a quick note, that's also why a lot of people, they'll say, well, my doctor told me that I can't use petroleum jelly on my face or things like that anymore. And that's because that's another fire risk. It's relatively low risk. Most people who end up having burns or things like that get it from smoking, being around an open flame, things like that. But still, there are plenty of other alternatives out there that are safer. So why even take a little risk?
Yeah, and you certainly don't want any petroleum products in your POC. Okay, so again, just reiterating this, the things to look for, that it requires a prescription, a high concentration of oxygen at all settings again. I'll just say some wording to look out for is sometimes they'll say up to 96%, up to 93%. To me, that's a flag. Anytime a description says up to, that says to me that it's not all the time.
Like those sales that are too good to be true, you can save up to 50% off.
Right. And it's also the same for battery life, right? It lasts up to 10 hours, or the battery
Yeah.
lasts up to 10 hours. Well, that's on the setting of 1. If you're actually that a setting of 1, you're just sitting, barely breathing. If you're up moving around, even on a setting of 1, it's going to drop. And when you get to whatever setting the device has, you're lucky if the battery will last you 2 hours. And we also want to look for FDA approved. It should say that it's FDA approved, but we're going to go through a little bit more of that and the surefire way to make sure that you're buying an FDA approved device. But we're going to jump into non-FDA approved POCs, how to spot them, and the concerns for using them.
So a few years back, a gentleman by the name of Bill Clark at the COPD Foundation was one of our earliest patient advocates. I think he was right there at the beginning. Not long after I started, came to me and said, "Hey, we're seeing that people can go on Amazon and electronic retailers and buy these machines that are calling themselves concentrators, and they really aren't if you look at the specs and things like that." And it seemed a little strange, but I said, let's check it out. And sure enough, you search for portable oxygen concentrator on Amazon, and it brings up a device like this that says very explicitly portable oxygen concentrator for travel, 2 to 9 liters a minute of household equipment. I mean, that sounds fantastic. It may weigh 17 pounds, so I don't know how portable exactly that is. But hey, we were just talking about how we can't have this equipment that is any kind of portable and still puts out more than 3 liters a minute. So, hey, also look at that. It's only $488. Whereas if I try to buy a reputable concentrator, an actual device, it's probably going to be more like $2,000 or $3,000. So I've got my Amazon Prime. I can get this here in a couple of days. This seems great. Unfortunately, and I think on the next slide, we have a little bit more detail. These are some of the things to look out for. First of all, most legitimate companies are going to put a little bit more work into spell check when they're creating some of their materials. You can see it's got a high concentration of 93%. Again, that sounds pretty good on this particular device. Going with the 2 to 9 liters a minute again, it's got a remote control. So this again is really looking like a really good device. Let's see what do we have on the next slide here. So yeah, this was one of the things that came off of that. And I think if we advance one more time, we get a little zoom in here. So this is what Mary was speaking to a little bit earlier. This oxygen concentrator goes from 2 to 9 liters per minute. When the number is 2, the oxygen flow is the highest. And when the number is 9, the oxygen flow is the lowest. And setting aside any potential language barrier, that doesn't really seem like it makes a lot of sense at first. But if you think about it, what this is actually saying, when you have this setting at 2, that's when you're getting the most oxygen. And if you turn it up to 9, then it's getting lower. And hopefully that might set off an alarm bell right there, because why is that? Why is the oxygen flow changing with the delivery here? Let's go again. And that's a highlight there. So despite these flags, we see some really nice marketing materials. Here's one that, again, very modern design. We've got some very professional and serious looking clinicians here and some very happy folks up in the corner. We've got, again, a nurse or an RT or some kind of clinician helping this gentleman out with his oxygen, and he's loving life there. We've got these devices that have this wide application. Pregnant women, sporters. I guess if you need that little oxygen boost there, you can take care of your whole family with these, including businessmen and travelers and anybody who needs oxygen. You're going to have a great time with this machine. And so again, it's very pleasant and it's like, wow, this could be the answer. It's less expensive. It's got more output. I don't really know what that 2 to 9 liters thing means, but obviously all these people are having a good time with it. So it's got to be pretty decent. And the next one. This one talks about oxygen production, which is not what oxygen concentrators do. It's very difficult to do that. Again, outside of a chemistry lab, you need to actually take what's there in the atmosphere and compress it down and concentrate it. And I don't mean to just pick on Amazon because these things are getting to be everywhere. This was, I think, a little bit over a year ago on Facebook. Found this from a place called the Oxygen Concentrator Depot. Now look at this thing. This fits in the palm of your hand and it's got an 8-hour battery and it's got different settings. I mean, this is going to be great. I don't even need one of those shoulder bags anymore. I can just pick this thing up and run with it. It's got power levels on there. It's going to be fantastic. And next. And then you go to this website for the Oxygen Concentrator Depot, and here are these very elegant looking gentlemen who look very ready and happy to help us out. The operations manager and the shipping guy's got 5 years of experience, and customer service has over a decade of working in major corporations. I mean, these guys know what they're doing, and it's a great little device. And if the last set of things wasn't great, this is definitely going to be the answer. Unfortunately, I was curious, and so I was able to download those pictures of that three-man team there, and I went to a website called Adobe Stock. You can get stock photos for whatever you're doing. And I found one gentleman was the casual man in warm clothing against the white wood. We've got the smiling designer with his arms crossed leaning on a wall, and we've got the smiling man. Now, again, this should be maybe a red flag if you don't actually have real people on your website. How can you trust anything else they're saying? How can you trust any of these claims? Because theoretically, if these are people who really know what they're doing and are really proud of the work that they're providing, they should be happy to put their face and their information out there. You shouldn't need to make what is essentially a fake website designed not to support people with clinical issues, but basically to separate them from some of their hard-earned cash. And this is again getting into some of the fine print and stuff like that. There were things like you couldn't return it if you opened the shipping package. There are all kinds of, we hear more and more horror stories about people who are just having bad experiences with these companies. I was just reading one the other day that was talking about how I got my device and I told them it wasn't working properly. And they said, well, you didn't get the right one, but if you pay another $150, we'll send you the better one. And they did that, and that one still wasn't working. And they said, well, that's still not the right one, and you'll need to pay us another $75. And it was just like this endless stream of, we're going to sell you more garbage as long as you keep buying it, instead of actually getting something that is worthwhile.
And like the other thing you mentioned with that one you read was it was saying it went up to X liter, XL. It was like 6L per minute.
Hmm.
And one of the responses they finally got after spending some of that extra money was, well, the L was for levels, not liters.
That's right. So again, it's basically predatory. And so we've started calling these things concentrators because they like to advertise that they're concentrators, but they are most assuredly not. And we actually put that to the test at one point. I think that's the next slide here. So a couple years back, we worked with Dr. Richard Casaburi, who is a very prominent pulmonologist out in California, who has a research lab out there. And now this slide is from our scientific paper that we did with it. It's not entirely clear, but we bought three of these concentrators. We, as in the foundation, also borrowed regular FDA concentrator, and we borrowed a compressed gas tank, and we sent them all out to Dr. Casaburi, who has this metabolic simulator in his lab, and he put each device at different breath rates and different levels on different flow rates and levels. He tested basically every combination that we could of all of these devices. The black dotted line represents the low metabolic. A was the compressed gas tank. So that's pure oxygen coming out. The higher the setting, the more oxygen is being provided. Device B is the continuous flow FDA approved concentrator. So that's why it stops at 2. And again, you can see it's going out regularly. As you turn it up, it's getting more oxygen into the metabolism. And the same thing with C, which is that same device that was on a pulse mode. And then that bottom row are the three concentrator devices. And you can see the first one there, regardless of what setting it was on, it put out pretty much the same oxygen. It did put out some, but it didn't change. Well, I'll take that back. It put out 7 liters of gas, but only a very small amount of that was actually oxygen. The rest of it was just basically taking room air from the room and putting it into your cannula. Machine E there only had one setting, and device F was the one that worked kind of sort of in the ballpark of the FDA concentrator, but didn't have any alarms on it. So you never knew if your sieve bed was running out or if there was an electrical fault or any other issue with it. We also didn't know how long it was going to last. So a couple other things to note about these devices. I can't remember if that's on the next slide or not. Okay, so this is where we put them all together. And we see that the COM, the compressed gas, it makes sense. That is pure oxygen. It's just coming out without anything to worry about. That's the one that works the best, that provides the most oxygen, I should say. And then everything else comes in varying levels below that. Again, a couple other things. First and foremost, I can't remember if this is on the next slide or not, but every time we ordered one of these, it disappeared from Amazon. It would say item not available. So there was no way, even in our order histories, to find the company again. And then it would suddenly reappear, maybe with a different model number or a different company name. But it was very difficult to see how anybody would get any support from them. One of them was marketed as portable, but had no battery. And then one of them didn't really change, and we weren't sure if it was a malfunction or if it was just the way it was designed, because again, there weren't really any alerts or indicators. So ultimately, we concluded that they were not fit for clinical use. And I'll go to the next slide.
The one thing I just want to add to that too, Mike, you mentioned there was no comments about how to change out the sieve beds. And that's something I haven't really looked into with these concentrators, but that's a very good point. How much are those sieve beds? Can you change them out? Or is it just as good until the sieve beds are dead? But if there's nothing alerting you that they're full, then how do you know how much the concentration is? It's going to start dropping once those sieve beds are full of nitrogen.
And I haven't taken the opportunity to actually acquire one of these things for myself, but I suspect some of them, like the little handheld guy that we saw a few minutes ago, might not even have a sit bed. I think they may just be a fan, basically, because one of those companies, I can't remember if it was that one in particular, I actually was interacting with them on Facebook and I asked them, how long does the sieve bed last? And I never got an answer. So again, I don't know. It's very difficult to take any of these companies seriously.
Yeah. And, if you've ever done just on Google a search of POCs, you're going to start seeing ads for these things on your social media too. So, next up, I'm going to show a few examples that pop up in my Facebook feed. And I'm just going to go through these somewhat quickly. Mike also talked about companies that seem to disappear. The companies selling the devices may disappear, but I've seen particularly Veron come up a lot. And so here's one. It says it's a dual oxygen delivery modes. And down at the bottom, you can see it gives pulse dose and continuous flow. But if you look at that smaller print there, continuous flow is 1.5 seconds. It gives a pulse every 1.5 seconds. That, by definition, is not continuous flow. Now, it may give a continuous pulse, a continually intermittent pulse at 1.5 seconds, but that is not continuous flow. So this is just to help you guys look at some of the language, some of the images to just know and to help people out. If you're in any of these Facebook groups, we get asked this a lot. So here's one that actually shows you the amount of oxygen it's delivering. And you can see here at the setting of 1, it's giving 90%, but at a setting of 6, it's giving 28%. And even if that setting of 6, it says oxygen flow L minute down at the bottom to the right of the 6 in that chart, whether that's level or whether that's liter, 28% is barely concentrated above room air. So if it is 6 liters, it's just blowing 6 liters at 28%. But it's not likely that it's blowing the 6 liters.
And let's remember that room air is only 21%, and it's diluted. When you take a breath in, you're not just taking in what's coming out of the cannula, you're also taking in room air as well. So it's already a bit dilute when it gets down into your lungs. And if it's only going to be 28% to begin with, then
Yeah. So you might say, okay, if I look for a chart like this where it's going down, then I'll know that this is lower oxygen at the higher concentration. I think a lot of this is people who try not quite subliminal advertising, but to get certain ideas in your head. So now this one does say up to 93 at 1 to 3 liters per minute. But if you look at this chart, you might be like, oh, that looks really good. But if we take a little closer look at that, the 10 liters is all the way over on the left, and it's reverse counting across. So again, I feel like this is kind of a false advertising to make it look better.
oh, absolutely. And again, that was even one of the big units that sits on the floor. It's not even a portable. So you can
Yeah.
see that it's not even just portable concentrators. They're starting to seep into the stationary market as well.
Oh, yeah. Oh, yeah, definitely. And one of the confusing things, so I didn't put that model in here. Veron does have an FDA approved model. It's not one they designed themselves. I think they rebranded somebody else's with permission, but that can be confusing because you see one thing with an FDA approval. So that's what I have on the next page. It wasn't a POC, but they have other items that are FDA approved. So it seems perfectly logical to assume they're all FDA approved. And that's not the case. You really have to be careful.
As I recall on their website, also they had home concentrators and stationary concentrators, and I think they had travel and port. They had very odd definitions of how they were defining their units, and it's a shell game.
Yeah. And I saw them saying that they were medical, that they're medical devices. So you really need to be careful. And I will just say the surefire way to make sure that the POC you want to get is FDA approved is to check out Running on Air's portable oxygen concentrator comparison chart. We update this periodically. And if you're looking at getting a device that you don't see, that you think is FDA approved, reach out and ask us. We may not be able to get to you immediately, but we will look into it because this is something that we do our best to keep up with.
And that's related to a question in the chat of how can AI help us identify concentrators? It probably could, but I would say that you don't even really need AI. If it's too good to be true, it's probably not true. B, you've got reference tools like Mary's chart here. And C, if you don't need a prescription to get it, then you definitely don't want it.
Yes. And they could turn around and say, send us a prescription, right? It still doesn't mean that it is an FDA approved device. So if they definitely don't require one, then you know it's not.
Which is
If
often what they use as a marketing plus is no, you don't need a prescription for this. You
right.
can just get it.
Yeah. You don't have to go through that hassle. So these will be on the email that I send out, but these are the resources. We do have a POC webpage that goes into a lot of this and has that chart on it. The last thing I just want to mention is the Supplemental Oxygen Access Reform or SOAR Act. And this is to help improve access, as the name says, to supplemental oxygen, particularly liquid oxygen, which is what people with higher flow needs. It's a better form of oxygen for them. It's lighter than a tank and it'll last longer than a tank. But there's other components of this. A lot of us just get our equipment dropped at the door, or somebody comes in and sets it up and says, see you later. And we don't know who to ask or how to get help. So this would also pay for a respiratory therapist to help train with the equipment and to do follow-up, because that's one of the things Mike mentioned earlier in that survey too. So if you have a problem or if you're not sure if your oxygen needs are changing or anything like that, there would be a respiratory therapist there. There's a patient bill of rights. that is a component of this, and then standardizing how doctors prescribe oxygen to hopefully get it to patients sooner. Because we know if we can't breathe, nothing else matters, right? So there's a QR code here, but I will be including a link to our website that'll give you more information on the SOAR Act. What we're asking is everybody to reach out to their members of Congress to ask them to co-sponsor this bill so that this will become law to help those of us on supplemental oxygen. And I'm going to stop sharing if we have any questions.
First, will this webinar be on YouTube? I know you mentioned you were recording it, but where can people catch it after the fact?
Yeah, hi, Carmen. Yeah, so it is recorded. We're going to be adding captions. I really hope that it is online by the end of January. We've
Yeah.
had a little issue with the person doing the captions for us. We have to find somebody new, so I'm hoping by the end of January.
And then our good friend Karen Dydemeyer says, thanks so much for this webinar, Mary and Mike. I refer people to your chart all the time, Mary. It's a fantastic tool. I know it must be a lot of work, and I will second that. I know that's been a labor of love, or at least the labor for you for a few years now, and it is an indispensable tool for a lot of folks. And it really does a nice job of illustrating the differences between the settings and why everything isn't just cut and dried like that.
Thanks, Mike. And I do want to mention that we're actually working on a comparison chart for home concentrators. Because as you saw from some of the concentrators we were discussing, they're moving those into the home unit market also. So we want to make sure that people know what's out there and can compare them and pick the one that's best for them. Of course, if you're getting it from a DME, you're stuck with whatever the DME gives you. But people often want to buy a second one either for work or for another home or something like that.
That's one last point for the SOAR Act. That's something that the Patient Bill of Rights and some of the improved reimbursement may address because we really want to get people the equipment that they need rather than what the DME company can afford. Because it's not that they're trying to be obstructionist or anything like that. It's that Medicare reimbursement for oxygen equipment has been slashed for decades now, and the SOAR Act is the first step to fixing that.
We do have a question. Does Invacare, where you fill little tanks yourself, is that a good continuous flow? I need 2 liters, so no other portables would work for me.
So I think that's Nancy's talking about a self-fill unit where it's basically a thing that sits on top of your stationary concentrator and has a little attachment where you can fill some of the smaller portable tanks. That could be a good option. I will say Invacare is no longer in the oxygen business. They sold all of their assets to another company. I'm blanking on their name right now, but it can be a good option because it's fewer deliveries for your supplier. It's a little bit better access for some of your needs. It would be a potential thing to discuss with your oxygen supplier just to see where you are, to see where things sit with reimbursement and everything else. But that's certainly a possibility.
Do other companies make a home fill?
I don't believe so. It was the rage for a minute and then it kind of faded out. And now it seems to be coming back a little bit again because people need oxygen. And with all of the other issues, we're also seeing where certain DMEs are limiting the amount of tanks they can get for
Right.
portability and everything else. So nothing jumps to mind. It's not to say it's not out there.
Okay. That's something we'll also look into. And so I will say that there are concentrators that go up to 2 liters and give 2 liters continuous. We have those on the chart, but because they're bigger, they're going to be heavier and the batteries may not last as long. So that's where you get into kind of a lot more of the pros and cons of which device does work for you better. All right. Mike, do you have just a couple more minutes? We have another question.
Yeah, I just saw that. Karen asked, do the respiratory therapists at pulmonology offices get trained on various POCs via continuing education? Sometimes. We'd like to do more of that. We'd like to see more of that. We recognize that there is definitely a huge need for that with RTs, with nurses, with doctors, with NPs, with PAs. There's a big knowledge gap there. And so that's something that we're looking to partner with a couple of different organizations with going forward. So more to come. So I will say yes, probably not enough, but more to come on that.
Yeah, and that's one of the things we're trying to do with the outreach and webinars like this too.
Yep, absolutely. So thank you very much, Mary, for putting this together. And thank you to all of the attendees.
Yeah, and I just want to read, Karen sent one more comment. I also found that battery life depends on the age of the battery. Yeah,
Mhm.
there's a couple things that will affect battery life. The age, certainly, as they get older, they hold less of the charge. Also, the faster you're breathing, it will run it down faster. So the same battery could last for 3 hours or maybe last for 2.5 or less, depending on your rate of activity, breath rate.
Temperature
And
could be an issue as I'm looking at our 18 degrees here in Michigan and looking down the barrel of 0 degrees by the weekend. So that can be a factor. There
yeah,
are a lot of things that go into that.
and that's one of the things we're looking to cover in one of our future webinars where we're talking about maintenance and things to consider. What do you need to do to keep the batteries at their optimal life for the longest? So stay tuned. Check us out on social media. We'll be letting you know. Okay, well, I want to thank Mike again. I want to thank all of you for joining us today. And I want to thank Mike for his respiratory therapist expertise and for all the work that he's done to get this message out, particularly about the concentrators. I think it wasn't on a lot of radars.
Always a pleasure, Mary. Thank you for the opportunity.
Yeah. Thank you. Have a great rest of your day, everyone.